I'm Keith Cameron, and this is a 3-hour course called How the Internet Works. Each hour is broken into 4 15-minute sections. The first section is entitled Network of Networks. The diagram you're looking at was created by crawling the web and recording each point or address on the Internet. It was done several years ago, about 5 or 6 years ago. It's available at opti.org/maps. It illustrates the richness of the Internet, and various subnets or domains are represented by different colors on the map, and it shows us some of the characteristics of the network. In particular, that the network is extremely dense and rich, and that it is non-hierarchical. In a large sense. There are some hierarchies involved in the way the networks are organized, but in general, there's no specific hierarchy like there is in the telephone network. All of these networks are bound together not by common underlying technology, but by the Internet Protocol or Internet Protocols. IP protocol, Internet Protocol, is a specific protocol for communications and connectivity. But there are many protocols that ride on top of that or are associated with it, hundreds of them in fact, and they all are able to communicate with each other because they rest upon this common foundation called the Internet Protocol. There are billions of users and devices on this global network at millions of sites, homes, businesses, retail outlets, mobile devices, and there are thousands of network operators. One of the really remarkable aspects of the Internet is that it was not designed from the top down, and it's not controlled by a central agency, but rather is a federation of thousands of these network operators. Some of them service providers, others are communications companies. And they work with each other in a cooperative way because of the standards that are built around the protocol they use, that is the Internet Protocol. It is not only designed through cooperation, although each network operator designs their own network in a way that suits them. In a larger sense, it is a collaborative design that uses these protocols, and the interconnection between networks is done in a very formal and structural way that enables communications between networks without necessarily exposing how the network works internally, that is, each of the interconnecting networks, and is cooperatively managed. The way messages are passed and the way traffic is passed is done through mutual cooperation, not through a regulatory body as it is in the telephone network. The network was not designed, or at least the protocols were not designed to be highly reliable. They were best effort protocols, and in that sense there was no guarantee of connectivity, availability, nor fidelity of delivery, that is, quality of service as we call it today. Local outages today on the Internet happen all the time. It's such a large network, that's not surprising. But globally, it is very resilient, and you can see from the picture some of the qualities that make it resilient. There are many paths through the network, and when one path isn't available, the network devices can discover that and take another path to get to their destination. The network has evolved to be a reliable service, even though it wasn't advertised that way, nor was it designed initially to be a high availability network. But because it is dense and rich in the way the paths are constructed, it is innately reliable. We haven't had, to my knowledge, a global outage of the Internet in a very long time, except for some planned outages very early in the foundation of the Internet. And the other wonderful part of the evolution is because it is content agnostic, the Internet can carry multiple modalities of media, that is graphics, video, voice, text, and it does it all with equal ease. It is now a part of our social fabric. 30 years ago, of course, this was not true, but people who are learning to use the internet today and growing up with mobile devices and video and all of the social implications of the network would be fine to manage their lives without it. So let's look at this network of networks and try to understand how it is put together and why I'm calling it a network of networks. We can all start by relating to our home network. Inside our home, we quite possibly have a desktop computer, a tablet device, and a smartphone, and can also have home monitoring or a wide range of IP devices in our home. That home network is usually connected via an access network for residential users, such as DSL or cable, into an internet service provider. Now, the access networks vary in capability and reliability and the way they operate, but to the home network user, many of those differences are hidden. Although there's unique technology in the access network, that technology is hidden because really the boundaries between these three different networks I've shown here, the home network, the access network, and the ISP, are all bridged by IP, the Internet Protocol. And so if you're looking in from inside the home network, you cannot really tell that you're operating on one network versus another. The Internet service providers, like Comcast or AT&T or Verizon or other operators, have access to the broader Internet typically through a Tier 2 network. The larger Internet service providers like Comcast and Verizon and AT&T don't need to go through a Tier 2 network. They can connect directly to their Tier 1 networks, or at least AT&T and Verizon can. They both have Tier 1 networks. Tier 1 networks are large optical IP routing networks that interconnect with all the other Tier 1 networks around the world and on a equal peering basis, and they provide interconnectivity to Tier 2 networks and other networks for global reach and connectivity. And we're going to talk more about each of these networks later in the courses, but this gives you a roadmap on what the networks look like and how they are interconnected. In turn, the tier networks and also Tier 2 networks have connections and peering points where they connect to content providers. So content providers are in hosting centers connected either directly or through a hosting company, and that is where the content resides in data centers, and so-called cloud services are also available in those data centers. Mobile networks work much the same way in the sense that they are really a collection of two different types of networks. A mobility network, which is a radio network with cell towers. There are over 100,000 cell towers in the United States, and that radio network manages the air interface as well as the mobility itself and allows people to go from site to site and maintaining IP connectivity. The mobile network operators collect all that traffic, and then that traffic connects again to the Tier 1 backbone. IP services that run over these two types of network, mobility and home networks, in general can't tell the difference because this is IP end-to-end. So whether you're getting content from YouTube on your smart device or whether you're getting it on a tablet at home, it's really all the same from the point of view of the content provider. We need to add one more important network to this picture, and that is the Internet peers. Tier 1 networks peer with each other on a settlement-free basis. That means that traffic passes among Tier 1 backbones without charge. The requirements to be a Tier 1 are that you have to be able to reach every point on the Internet, and in addition to that, Tier 1 network providers have requirements for settlement-free peering. For example, AT&T has the requirement that interconnecting Tier 1s must have backbones at least capable of carrying OC192 traffic, that is 10 gigabits per second. And that requirement was put in place some years ago, so today the requirement might be somewhat greater. In addition, to peer with AT&T on a Tier 1 basis, you must interconnect at multiple points within the United States. That is required so that each network has the ability to hand off traffic at the most efficient point and is not required to haul traffic across the U.S. Simply because the interconnecting peer doesn't have adequate interconnection. So those requirements for Tier 1 interconnection on a settlement-free basis. Connection with Tier 2 networks are on a settlement basis. That is negotiated between the network operators. Tier 2 networks tend to have backbone networks, but they don't meet all the requirements of a Tier 1. That is, they don't interconnect with all the other Tier 1s in the world, nor necessarily do they meet the backbone requirements of somebody like an AT&T. ISPs tend to be Tier 3 networks. These are somewhat informal designations, but the Tier 3 networks tend not to have backbones, and they tend to be specific purposes, like the two I've shown, the mobile network operator, which is an aggregation network for radio traffic, and the ISP for the home network aggregates either DSL or cable modem traffic. Now, the symbol I've placed in the aggregation networks is really a symbol for aggregation and concentration. The aggregation and access networks tend to have hundreds of thousands or even millions of endpoints in total, and they concentrate that traffic and deliver it on fewer but higher speed connections to the Internet. The other interesting characteristic about access networks is they tend to be highly asymmetrical. That is, we can expect to see a lot more traffic being delivered to the home than is being originated from the home. That's because the traffic generally comes from content providers, video, or other forms of media. The same is true in the mobility network. Mobility networks are highly asymmetrical, with more traffic going to the subscriber than comes from the subscriber typically, although the advent of very high density cell phones and cameras is changing that somewhat, and we're seeing more and more content coming from the end users. The picture that we look at here, we have to ask ourselves, where is the Internet protocol actually being enforced? And the only places we can be guaranteed that the IP protocol, the IP family of protocols are going to be enforced are at the boundaries between the networks. So we can be pretty sure that the boundary between the home network and the access network is an IP related exchange, and the ISP connecting to the Tier 2 network, that enforces the full family of IP protocols in the suites. Same is true of Tier 2 networks and their interconnection with Tier 1. Inside each of these networks, inside the Tier 2 network and inside the Tier 1 backbone, there's no requirement to run IP. In fact, we'll find that different protocols are being run inside these networks. Often they're layer 2 networks, but in the case of backbones, we'll find there's another protocol called multi-protocol label switching which is very efficient for backbones of scale, and also gives the added advantages that it supports multiple edge protocols such as IP, IPv4, and IPv6, which we'll get more into in later sessions. The next slide is simply a list of suggested reading for this session, and in subsequent sessions I'll provide more suggestions for your reading enjoyment.